Hi guys, this is our bonding lab, so follow along and collect your data. Okay, first we're just going to look at the sample's name and formula and find out what elements are here. So we're going to take a look at rust. Fe is our first element. Let's look it up. Fe is here. It's over on the left side, so that is a metal. O is over here on the right side of the zigzag. So that is a non-metal. Let's take a look at the rust, Fe2O3. It is a solid. It is red-brown in color. And it's more of a powder than a crystal, so I'm going to say not. Okay, let's go on to our next one, sugar. Okay, sugar, let's take a look at its formula. Let's look up carbon. Carbon's over here on the left of the zigzag, the right of the zigzag. That makes it a non-metal. Hydrogen is our exception. It's on the left side, but it is still a non-metal. Oxygen is over here on the right side of the zigzag and is also a non-metal. So we have all non-metals in sugar. Let's take a look at it. Sugar is a solid. Sugar is white. And sugar, these are definitely crystals. Last, we have mothballs, naphthalene. Okay, and let's take a look at the formula. Let's look up carbon. Carbon is over here on the the right of the zigzag. That makes it a non-metal. And hydrogen, even though it's on the wrong side, the left side, it is a non-metal. You can see here, it is a solid. It is white. And it's sort of a powder crystal. It's sort of in between. Okay, I'm going to say in between. Now we're going to see which one melts. We'll look at the relative melting points. So let's put them all here. So I have this in a pan. I'm using aluminum foil that I turned up into little boats. And I have it on like medium-low heat. You can zoom in here and you can see this is the naphthalene, the mothballs. You're looking closely, you can see that it's already starting to melt. So let's stay on that one for a while. You can see again, starting to become a liquid. And let's take a look. The rust is not becoming a liquid, not melting, and the sugar is not melting. So far, the only one that is melting is the naphthalene, the mothballs. You can see it's starting to melt. Turn into a clear liquid. In fact, it's pretty much almost gone. Okay, we're gonna okay, that's pretty much there. We got to keep this going. We might have to come back to this because it might take a while. This one definitely melted first, so let's record that. Okay, so if it melts first, it melts very easily. So that was mothballs. So its melting point is low. Out of the three, this had the lowest melting point. Because it melted quickly. It melted with very little energy. So that's a low melting point. The other two are not going yet. We're going to keep coming back and checking on them. I'm going to take the naphthalene out. Just so it doesn't evaporate all the way. Okay, anything happening here yet? Not yet. Okay.
It's changing color.
Is it changing color?
Yeah, a little bit.
A little bit? Okay. Okay, let's keep going. We're going to come back. We're going to go on to do electronegativities while that is warming up. Electronegativities are table S. Let's look here. It's in the middle column, electronegativity, and we look up the element and the number. So we need to look up the electronegativity of Fe and O. Now, those are subscripts. We don't need to multiply by those numbers. We just need the electronegativity of one Fe and one O. So let's go find Fe is 1.8 and oxygen 3.4. Okay. When I subtract those, 3.4, let's zoom in a little, 3.4, take the big number minus the small number. You can use your calculator. And when I do that, I get 1.6, a difference of 1.6. Okay, next I'm going to do carbon and hydrogen. Carbon is 2.6 and hydrogen is 2.2. And when we subtract 2.6 minus 2.2, I get 0.4. Okay. We also, I'm going to have to squish this in, we also have carbon and oxygen. Okay, let's take a look. Again, we have carbon and oxygen bonds in here as well. So I'm just going to squish this in. Hopefully you'll make yours look nicer. We already know carbon is 2.6. Oxygen, this time, is 3.4. So if I subtract those two numbers, 3.4 take away 2.6, I get 0.8. So I have two different bonds going on here. Okay, let's go back. Something's happening here with our sugar. Our sugar is starting to change color. It's starting to finally melt. In fact, if you've ever made caramel for flan, right, you melted the sugar and it turns a dark color like that. So that, and the rust is still not changing. Okay, we'll take this off so it doesn't burn all the way. Okay, still hot. So let's record that. So let's go back to melting point. Mothballs were the lowest because they melted very quickly. Next, we're going to say a medium melting point for the sugar. And the rust did not melt at all. And that made it the highest melting point of the three. Let's continue on with our mothballs. Has carbon and hydrogen, which we've already done. We know carbon is 2.6 and hydrogen's 2.2. When I subtract, I get 0.4 again. Okay, so this rust has the biggest electronegativity difference, then sugar with its carbon-oxygen bond, and then mothballs have the lowest electronegativity difference. We're now going to see how they dissolve in water and record. So I have 3 cups of water. We're going to start with rust, the Fe2O3, and just put a little bit in. No, it doesn't have to be a whole lot. And I'm going to use the opposite end actually just to stir. And you can see it does dissolve. It mixes very evenly throughout. Okay. So, is it soluble in water? Yes. It is dissolving or soluble in water. Now let's try sugar. Again, it's a little bit. I'm going to use the opposite end just to stir. And this one's taking a little more time, but it is dissolving. So I'm going to go back and record, yes, it is soluble, it is dissolving. Next are mothballs. Again, just a little bit. And I'm going to mix. Okay, if you can get a close-up, you can see how they're just kind of floating on top, or some are sinking to the bottom. It's not really mixing. Okay, so let's take a look at the others. Again, that dissolved all the way through. The sugar dissolved all the way through. And the naphthalene is really just, no matter how much I stir, you see all these chunks. It is not dissolving. So we're going to say no. For solubility in water, the mothballs is no, and the other two are yes. Now we have something that you won't have at home. You won't be doing this next test at home. The next test is hexane. So we're going to put out just a little bit. Because it is a kind of nasty solvent. I'm not going to use too much. I don't want to waste. Okay, and we're going to try to see if they're soluble. So I'm going to add a really small amount since I'm only using a small amount of liquid here. Okay, and this time I'll just use this side. And you can see how it's not spreading out. It's just sort of sitting on the bottom, clumping up. It doesn't want to mix. So that's insoluble. So soluble in hexane? No. Okay. And that's, again, compared to our water. Next, we're going to do sugar. Again, small amount since I'm using a small amount of liquid. Let's keep using the spoon. Let's take a look. Really mix. Can you see on the bottom there that it's still just sort of sitting? I can stir, stir, stir. And really, it's just all sitting there on the bottom, that big clump. So that's also a no. And last, we're going to try our naphthalene, our mothballs. Okay. And remember before they were floating. I do have some big chunks in there, so that's going to be a bit of an error. But we're going to try to mush them up. Okay. You can see that it's starting to dissolve. And it's very different than what it looked like in water, where it's just sort of floating and clumping. Here, it is mostly dissolving there. So coming back, that's a yes. Okay. So make sure you have all of your data. Take a last look. And you're going to be doing these same experiments, except for the hexane, with your choice on the next page. Okay, that's all.